there may be adult language if I get very excited. It's Friday the 13th. Ooh. If I'd realized before this morning that it was going to be Friday the 13th, this would have been a lot spookier, but I didn't, so it's not. So sorry about that. But we will be talking about lean configuration management. And it has this title because I had to do a talk at Configuration Management Camp, so I thought, configuration management, lean. What happens when we put those things together? And so configuration management here is to be understood very broadly, but it is very central in what we do in creating high-performance organizations. So think high-performance organizations, configuration management, and how those two things are related to each other. And if you only have space in your brain for 4 things, which after several nights of partying is probably the case, these are the 4 things that you should try and make room for in your brain. One thing that I'm at pains to emphasize throughout this is that throughput and stability, people think that going fast means breaking things, and this is pervasive. One of the things that I particularly hate this year is Gartner's bimodal IT, and there's many reasons why bimodal IT is total nonsense. But one of the reasons is that it's premised on this idea that there's a trade-off at the heart of software engineering and building high-performance systems and organizations, and I'm here to tell you that's not true. The heart of the connection between lean and configuration management is actually culture. Anyone who saw Nicole's talk a couple of days ago, I'm going to expand on some of that and give it a slightly different interpretation, but the key thing here is that culture predicts information flow, and information flow predicts the performance of the organization you work in. So there's a nice kind of causal relationship we can actually demonstrate using the data. The lean bit is really about this. It's about building quality in at the source. I come from a development background. I've done some sysadmin as well. And I mainly talk to developers, and the main thing I tell them is, in DevOps, the operations people aren't going to have capacity to change the way they do anything if you don't start fixing your code. And so there's a big piece of this, which is building quality in at the source, so we don't have to fix it downstream. And that, again, comes back to the lean configuration management thing. And then the final thing I want to say is that we're all product developers now. And fundamentally, systems engineering is about doing product development at the platform level. And that's, I think, the big change that we're seeing in the industry right now. So I want to start by talking about, one of the things I'm heavily involved in is the DevOps movement. And I want to talk about what kind of caused me to come into the DevOps movement. And that is, I was working in a startup in 2000. And in 2000, I was doing continuous delivery. I was FTPing files from my workstation directly into production. And we had a rollback process as well. And the rollback process was my colleague, who was the other engineer in the organization, would FTP his copy of the files into production to rollback. So we had a pretty good process for deployment and for rollback. We didn't have version control or anything heavyweight like that. I wouldn't recommend that today. It was very productive at the time. But having production as your single source of truth, I don't know, probably not very sensible. And then I went to work at a consultancy where we were doing a bunch of stuff with big companies, and I was like, oh my God, this is terrible. And it was a really rude awakening to the life of many people working in big companies. Who works in a company of more than 1,000 people here? Wow, lots of you. Okay, so this talk's for you. Maybe you work in nice ones, maybe you don't. But the typical pattern I find is this. So this is my diagram of the enterprise. On the left side, you've got the golf-playing cadre. And then in the middle, you've got the engineers. On the right, IT operations. Martin Fowler assures me that this is valid UML for the big ball of mud that you're running in production. And of course, we have the machine that goes bing, that lets you know that everything's working. And so what happens, this is not too bad, right? We don't have outsourced testing, we don't have outsourced development, so this is not nearly as bad as it could be, but it serves to illustrate the point. And so what happens when we press play on this static diagram? Well, what happens is some business person comes off the golf course after a particularly fine round of golf with a fabulous idea for an exciting new product. And after many weeks or months of going through the budgeting cycle and analysis and estimation and design and planning, an enormous document lands on some poor project manager's desk, and then the engineering team spends weeks or months or years actually building the thing before tossing it over the wall into IT operations, where the poor ops people have to try and wire it up and make it work. Bing! At which point, the engineering team that built that thing disappears off and goes to do something completely different. And that thing they built lives on in production forever. So who has actually retired a system in the last year? Well, this is an advanced crowd. Well done. I often go to enterprises and people are like, no, retiring systems, are you mad? We can't make a business case for that. And so there's many problems with this paradigm, not least of which is the fact that it takes too long to get anything done. It's really, really slow. The most expensive and painful and long way to find out if your product idea that you came up with on the golf course is any good is to go and actually build it. And yet that's what we do. And it takes a really long time. And the solution to this is supposed to be agile. And agile is inflicted, first of all, on the engineering organization. Everyone goes to the 2-day Scrum training, and now we're taking orders from management standing up rather than sitting down. And that enormous backlog of work that we can't ever complete is prioritized and estimated, and now we're agile. How do we think the rest of the organization reacts to this exciting news? Are they thrilled and full of joy? Not normally the case. What we find is that, Agile is all about better collaboration between business and engineering, and that's awkward for both sides because it means the business people have to spend much less time on the golf course and much more time in the engineering floor, which is normally not that well appointed and full of engineers. And then the engineering people have to talk to the business much more, which is awkward for them because the whole reason people go into engineering is so they don't have to talk to other people. And so there's kind of problems all around with this paradigm. It's also painful for operations because instead of having some nasty pile of crap come over the wall once a year, now we have miserable, undeployable code coming over the wall all the time. And the only natural reaction to that is, for operations to be like, please stop the madness. Please make it stop. And the engineer's like, what? What are you talking about? We're doing TDD. We have nicely decoupled, well-encapsulated systems, and the operations people are like, well, that's lovely. It's a shame it doesn't actually work. And there's a natural and logical reaction to this dynamic, and that's to create a barrier. And the barrier is encapsulated in the change management process, and the job of the change management process is to make sure that nothing ever changes. And thank you. It's funny because it's true. And so the industry standards methodology we find in the software development lifecycle is what I like to call, following Dave West from Forrester, water, scrum, fall. And so to get anything done, to go from golf course on the top left to measurable customer outcome on the bottom right, we have to go through this miserable kind of budgeting and estimation process, which delivers very little value, frankly, in terms of actually making sure that the thing you're building will actually be useful or make money or anything like that. And then you've got the agile bit in the middle, and maybe you're doing the analysis and development and testing in these nice little iterations, but nothing's actually going out to users at the end of that. Oh no. First, we have to go after dev completes to centralized testing, and it always kind of interests me that in the big program management charts, there's a phase for testing, and there's never a phase to fix the bugs that we found in testing, so I don't know what's up with that. And then if you actually manage to fix some of the bugs, then you have to toss the whole thing over the wall into IT operations, and some poor team of people has to make that work and then spend many nights getting alerts as it fails to scale, if you're successful. If no one actually wants the thing, it's great. Everyone can relax because there's no alerts because no one's using it. So yay. And so the question is, can we do better than this? Who recognizes this or has a friend who's in a company which follows this methodology? Okay, lots of you. And so the question is, can we do better? The answer is yes, of course we can do better. So I like to show this slide, not because I massively endorse Amazon, but because it's a great way to blow people's mind, frankly. And many of you will have seen this already, I'm sure. This is from 2011 from Velocity, and their latest numbers are an order of magnitude higher than this. They're making changes to production every 11.6 seconds, up to 1,000 deployments in a single hour. On average, 10,000 boxes receiving those deployments, up to 30,000 boxes receiving a deployment. And this is, of course, aggregated across the thousands of services that make up Amazon. But that's already interesting that they actually have the ability to deploy these services independently of each other, and crucially, treat those services differently based on their risk profile. And this is another big problem I have with the whole bimodal IT thing is, great, we've gone from one size fits all to two size fits all. Yay, progress in IT. And in fact, what we actually want is every service to have a risk to manage every service according to its risk profile. So, if you're working on the recommendations engine, it doesn't matter if you break it a bit. If you're working on the engine that processes credit card payments, that has a somewhat different risk profile. I'm pretty sure they're not deploying changes to that every 11.6 seconds to production, and that's okay. But what we typically end up with is, well, guess what? Our service-oriented architecture actually requires that we deploy the entire production landscape every time we need to make any change. And so, bimodal is kind of crazy new thinking in that context. So the key thing I want to point out here is that we often think in terms of the iron triangle of project management, that if you want to go faster, well, guess what? We're going to reduce quality. If you reduce scope, that's going to reduce quality. And we're kind of constrained. And I think the big news here is this is not true. The inspiration for a lot of the DevOps movement is from manufacturing and the lean movement in manufacturing. And what Toyota proves in manufacturing decades ago is that you can change the game, that we can actually get people what they want faster with higher quality and lower cost, and that it's not actually a set of trade-offs. And that, I think, is what DevOps and continuous delivery. I mean, the reason I'm here today, 5 years on, is because this stuff actually works, much to my surprise. I'm very happy about that. But these ideas really work, and they do change the game. And I have the data to prove it. So me and Nicole Forsgren and Gene Kim worked on the State of DevOps report. There's a new one out this year, but I like this cover better. And the big news that we showed last year was that IT actually matters, and we've heard that IT doesn't matter for years, and it's nonsense. Firms with high-performing IT were twice as likely to exceed their organizational performance goals, and we measure organizational performance in terms of profitability, market share, and productivity. The second big news from this survey is we found a statistically valid model for measuring IT performance. So what is IT performance? Well, this is a model, right? So it doesn't capture everything, but it captures some things that we think are important and which the statistics show are internally consistent and valid. So lead time for changes and release frequency are our two throughput metrics. This is how fast you go. And then we had two stability metrics, time to restore service and change fail rate. Change fail rate is not actually change fail rate because, as we know, changes never fail. They just get emergency patches until they work. And so we asked that question in a way that makes that clear. But the interesting news from this is that high performers do better on both of these measures. It's not that if you increase throughput, suddenly you can't restore service anymore and all your changes fail. That's not the case. The people who do really well on throughput also do really well on stability. They have high levels of stability, they can restore service faster, their changes fail less frequently, and that's because the same practices that enable you to move fast also enable you to create high stability systems. Where you can restore service rapidly and where you actually have some level of confidence that when you deploy your stuff, everything isn't going to go to shit. So Nicole and me and Gene were really interested to find out what it is that enables this. So what are the practices that correlate with high-performance IT? And the top one is using version control. So I wish someone had told me this in 2000. And then I wish someone had told me not to use Visual Source Safe. And the interesting thing about this top one is that code is actually not the most important thing to keep in version control. It's more important to keep your app configuration and your system configuration in version control than it is to keep your code in version control. And when it comes to things like restoring service, this is really important. If you have something go down in production, some piece of hardware that's hosed, if you have to actually log in on the console and configure the thing, that is not going to result in a predictable time to restore service. What's essential is the ability to restore service using purely automated processes using only information stored in version control. So that's really important in disaster recovery. Can I run a bunch of scripts, or ideally have the system kind of automatically detect that there's a problem, and when we put new hardware in, it'll just reconfigure it in a fully automated way, purely using information in version control. And it turns out the same practice is also really important for throughput. The ability to create testing environments on demand through an API, again, relies on being able to provision them purely from information in version control. So this is a great example of a practice which enables both high throughput and high stability. Number two, we get failure alerts from logging and monitoring systems, not from, say, Twitter. And then two things that are very dear to my heart. Number one, developers merge their code into trunk daily, and still the most controversial thing that I say after, coming on 15 years after the papers were written about continuous integration is developers should merge their code into trunk daily, not into feature branches. And then, the raving hordes of developers come and attack me on stage, no, it's madness, it can't work. And broadly speaking, engineers fall into two camps. The camp that thinks that, of course, everyone works off trunk, and then the camp that thinks that is madness, and of course we have to have our feature branches, because basically developers like to sit with their headphones on and write in feature branches for days and days and days, and then merge it into trunk when they're sure it's absolutely perfect and the gold plating has fully dried. And then the other piece is developers learning to break up large features into small incremental changes. And this is the hardest skill for developers to learn, is how to take big features or big architectural changes and break them up into small incremental steps. That's one of the things I look for when I'm interviewing developers is, do they understand how to do that? And it's really hard to do. It's the biggest kind of culture shift that developers have to make. It's really difficult to get developers to change the way they develop. It's really ironic in an industry which is premised on change, that if you try and get people to change the way they do things, it's no, you're evil. Friday the 13th. And then the DevOps thing, when developers and operations teams interact, the outcome is generally win-win. So using some statistical magic that I don't really understand, but Nicole's here, she'll explain it to you if you ask her, we found out the factors that predict IT performance. I'm allowed to use the word predict, but I'm not allowed to use the word cause. Is that right? Thanks. So number one was really interesting. So I love surveys. They're such a great source of confirmation bias. But one thing that we were particularly keen to look at is change approval processes, because everyone hates change approval processes. And so we looked at various types of change approval process, in particular peer review, where developers basically look at each other's codes through pair programming or through code review, versus external change approval processes where you have to put things through a cab. And what we found was, perhaps unsurprisingly, that peer review change approval processes massively increase IT performance. And I'm like, hold on a minute. I'm sure it increases throughput, but surely it's going to have a negative effect on stability. And the surprising thing for me is that that's not the case. It has a negligible effect on stability. It doesn't make stability go up to have peer review change approval processes, but it doesn't make it go down. So almost zero impact on stability to have developers review each other's code rather than a change advisory board. And so, I used to go on a rant and say, change advisory boards are useless. I don't do that anymore because the guy who's in charge of ITIL is quite scary, and he kind of came out to me and was like, that's not true. And I'm like, okay. And he basically said, which I think is right. Change advisory boards are good in as much as they coordinate between all the different teams that are involved in putting out a release. And they're also useful in terms of actually the governance around change management. So what's our change approval process like? How do we practice continuous improvement around our change process and measure the effectiveness of the change process? I can get behind that. What I can't get behind is the idea that a bunch of people who don't know the code base can understand the impact of the changes on production. So who's written code in this room? Yay, keep your hands up if it's never happened to you that you've written a change where you're like, that can't possibly break anything, and then it's broken something. If that's never happened to you, keep your hands up. Right, okay. I mean, it's a trick question, right? But well done, you're all paying attention. I mean, it's certainly happened to me. You're like, that can't break anything. It's a CSS change. And then production goes down, and you're like, phew, at least it's not me. And then, 15 minutes later, someone's like, so, Jez, that change you made. I'm like, yeah, the CSS change? And they're like, yeah, that brought down production. Shit. So here's the thing, right? I know the code base really, really well. I'm in that code base every day, writing the codes. And I can't predict the impact of these things. So what chance is there that a team of people sitting in a different room or a different country who don't know the code base can read, what in many cases is tens or hundreds of thousands of lines of code change created by hundreds of developers over months and predict the impact of that on production? It's madness. It can't possibly work, which is why it doesn't work, which is why it's nonsense. I mean, I used to work for a consulting company. The consulting company did some work for a large European electronics manufacturer where the change approval process was that you sent a spreadsheet with 7 tabs via email to a different country. I mean, at least they were using email, not post. And a group of people looked through the spreadsheet and didn't really understand what was in it. So they would ask the developers a bunch of searching questions like, have you tested this? Have you practiced the rollback procedure? And so forth. And if they liked the answers, they'd approve the change. And the developers knew that the change managers had no idea what was in the spreadsheet, so they would take the last one, copy it, change a few fields, and then email it through. And the change managers knew that the developers knew that change managers had no idea what was in the spreadsheet, and they were basically just ticking the boxes so that when something went wrong, they could say, it wasn't our fault, we followed the process, look, here's the bit of paper with the check box, right? And so what we have at this point is what I like to call risk management theatre. Thanks. I really want this to become like a commonly used term of art in the industry, so please tell other people this story. It's a performance designed to give the impression we're doing an effective job of managing risk while actually making things worse. It has no positive impacts on actually our ability to manage risk at all. So what's better, it turns out, is having peer-reviewed change approval, where developers look at each other's stuff either through pair programming or through code review, which is, unsurprisingly, the process you find at many high-performing companies today. So version control, everything, we've talked about that. Proactive monitoring, talked about that. High-trust organizational culture, we're going to come back to that because that's important. Win-win relationship between dev and ops, also important. The other thing we looked at is what predicts organizational performance. So organizational performance, you'll remember if you cast your mind back, is profitability, productivity, and market share. So what predicts organizational performance? Well, it turns out, as anyone who's studied organizational health over the last 50 years will know, is job satisfaction. Like keeping your people happy, it turns out, is quite important if you want to actually be profitable and have market share and build good products. So this is reflected in the data. These top 5 questions, 4 questions are the ones that most highly predicts org performance. Net promoter score for your organization, being satisfied with your job making good use of your skills and abilities, and having the tools and resources to do your job well. And then the 5th thing is having actually a feedback loop from production to your business. Gosh, if only we paid attention to the effects of what we did on our customers in production. That would be amazing. And so what predicts organizational performance? Well, the biggest predictor of organizational performance is culture. And culture is one of these things that people think is touchy-feely. We put some rigorous quantitative analysis around culture, which was fun. My favorite book on culture is by this guy, Edgar Schein, called The Corporate Culture Survival Guide. He's not necessarily the most concise person, but he does say, he has this nice quote about culture. And I think 2 things about this. It's tacit assumptions. So it's not like the culture is ever spelled out anywhere. It's just the way you learn how to behave. And often that's not actually something you consciously are aware of. You're just kind of subconsciously aware that when the head of marketing walks past, you kind of cower slightly to this side of the corridor. Anthropologists observing your behavior would be able to make all kinds of interesting comments on that, but it's not something you necessarily consciously reflect on. You learn subconsciously how to work effectively within the organization, and then if you reflect on that, maybe you have to give briefings to new hires, you might actually be like, oh yeah, that happens, and then that's why that happens. But the culture is basically what has made the company successful. And so it's very hard to change the culture because you're basically saying, yeah, you became really successful, but stop doing all that now because it's bad. That's hard to do. The other quote I really like about culture is from Shanley Kane, who has a great magazine called Model View Culture. She says, our true culture is made primarily of the things no one will say. So again, tacit assumptions. Culture is about power dynamics, unspoken priorities and beliefs, mythologies, conflicts, enforcement of social norms, creation of in-out groups, and distribution of wealth and control inside companies, which I think is pretty accurate. So how do we measure culture? We used a model that we actually took from healthcare and aviation. This is a guy called Ron Westrom who created a typology in his study of safety outcomes in healthcare and aviation. Actually, John Allspore told me onto this. There's this thing, if you email John Allspore, he will basically reply with a PDF of the paper that he's read most recently. You're like, hi John, how's it going? Read this paper. It's, academic papers as a service. And so he once sent me this paper, and I'm like, that's really good. I mean, and you should read them because they're normally really good, and you're like, whoa, amazeballs. And so Ron Westrom was studying safety outcomes in aviation and healthcare, and what he found is he could predict the safety outcomes by how effectively those organizations processed information. And he created a typology to kind of expand on how organizations process information based on whether they were power-oriented, rule-oriented, or performance-oriented. And there's these kind of 6 axes, so how effectively people cooperate, how we deal with bad news, so messengers. Messengers, in this case, are people bringing bad news. When people bring you bad news, do you ignore them? Do you shoot them? Or do we, in fact, train people to bring us bad news so that we know what's going on so that we can actually do something about it? And this was, there's a great story that I really recommend that you listen to on This American Life about NUMMI, N-U-M-M-I, which was a joint venture between GM and Toyota. And what happened was, basically, GM had this really badly performing plant. They shut it down, and they did a joint venture with Toyota, totally separately. And Toyota, the union leaders from the plant in Fremont, 30 minutes from where I live, convinced Toyota to rehire them. And these were people who were performing so badly, and the managers were so horrible that the workers would drink and take drugs and gamble on the job and sabotage the cars by doing things like putting Coke bottles in the doors so that they would rattle. And so they shut down the plant, everyone got fired, they started up the joint venture, union leaders convinced Toyota to rehire the same people. And the GM people were like, are you nuts? And then they sent them all over to Japan, to Toyota City, to learn the Toyota production system. And they came back, and within several weeks, they were producing the same quality cars that Toyota was producing in Japan, and higher quality than any cars that were produced in any GM plant in North America. Same people. And what this shows us is that it's not the people that are the problem. Whenever we have bad actors, we don't have bad actors, we have a crappy system. Deming says a bad system will beat a good person every time. And so one of the things that happened during that training in Japan is that the Japanese managers would ask the American managers, how's it going? Everything great? And the American managers would be like, no problem. And the Japanese managers would be like, anything that we should know about? Have you kind of, like, no problem. How's everything going? No problem. And eventually the Japanese managers got so pissed off, they were like, no problem is a problem. The whole point of management is to find out what the problems are so they can help the people working for them fix them. That's like the main goal of management, is helping people problem solve. And so if there's no problems, you can't problem solve, and you can't get better. So we actually need to train people to bring us bad news so that we can fix the problem, or address the problem, or do something. How do we deal with responsibilities? Are responsibilities avoided? Are they narrowly defined, so we have a neck to choke? Or do we share risks between different parts of the organization? How do we deal with bridging between different departments? Does everyone just point at the network administrators when there's an outage, or do we actually work together to find the problem effectively rather than pointing fingers? And then 2 things that are particularly interesting to me here. One is how we deal with failure. Now, we all work within complex adaptive systems, right? And in complex adaptive systems, you can never predict the consequences of your actions. Every action will have side effects, and we never have perfect information, especially not management. And so in the situation, when there's an accident, when something goes wrong, when there's an incident in production, a typical reaction is to find the person responsible and then fire them. And every time you're tempted to do that, I want you to conduct this little thought experiment. If that had been me in that situation with that information and those tools available, could I have made the same mistake? And often the answer is yes. I could have made the same mistake. Anytime an investigation into an accident ends with human error and let's fire the person, we've done a terrible job. That should be the beginning of the investigation, and we should be looking to find out why that person didn't have the information and the tools they needed to make a better decision. and then do something about that. So in a complex adaptive system, failure is inevitable. And this is why kind of the traditional change management approach is broken. We've been trying so long to prevent failures and have this mean time between failures attitude. And once we accept that failure is inevitable, which it is in a complex system, we have to think, how quickly can we restore service? And that has to be our focus. And that requires cultural and architectural change. So failure should never lead to scapegoating or justice. It should lead to inquiry. How can we make the system better? Dan Milstein has this nice quote. He says, "How can we all plan for a future where we're all as stupid as we are today?" And then my favorite thing, how we deal with novelty. Is novelty implemented? Does it lead to problems, scope creep, or is it crushed? And the interesting thing to me about this is that the same factors that predict safety outcomes also predict our ability to innovate. That's really interesting. Same things that predict safety also predicts our ability to innovate. So we know that culture impacts job satisfaction impacts organizational performance. So there's a clean line through from culture to organizational performance. I want to turn back to some of the other factors that we looked at in IT performance, and particularly lead time. So lead time is one of these things that is actually quite hard to measure. How many people know what the median lead time is for changes from version control to production in days? Does anyone actually know that number for their organization, median lead time from version control to production for changes? Okay, like a few people at the back. That's great. It's not actually a very widely known number. And what you really want is actually the distribution and to find out the shape of that distribution and the levels of variability and so forth. But it's super, super important because that number tells you lots of important things about your organization, like how quickly can you restore service if you need to push the previous version into version control, or if you need to provision a bunch of servers over here because some servers over here have gone down. How quickly can I get a critical fix to users? If it's a one-line fix, how quickly can we get that fixed into production? Not using the emergency change process, but using the normal change process. So some people ask me, like, what should be the goal for this? And my answer is, the goal is you should be able to use your normal change process for emergency changes. Because what don't we do in the emergency change process? Testing. How good an idea is it when your system is going really badly wrong to not test the fix? Obviously, it's a terrible idea. Another rhetorical question. Sorry about that. So we should be able to use our normal process for emergency changes, and that's really the goal here. And so this number tells you how quickly we can actually do one-line changes and get them into production without making things worse. And then finally, how quickly can I validate if a feature is valuable? So instead of going and building the whole system to find out if someone will actually buy it, I think the greatest invention in the last few years in big companies is this idea of it and taking an experimental approach to product development. Instead of building the whole thing, how can we run an experiment to find out the important information, which is, are people actually going to like this feature? Is it going to impact the bottom line? And this is one of the major reasons why Amazon invested in this capability. I'm going to tell a story about this a little bit later, but it took them 4 years to re-architect to do this. It was incredibly expensive and painful. They had to completely re-architect, huge amounts of investment to achieve this. Continuous delivery is really hard, and it requires a ton of investment, and it will be super painful. And one of the reasons they did this is so they could run A/B tests in production, experiments to validate whether the feature will be valuable. And I have a whole bunch of data, or I don't, in fact. I found the person who has the data, a guy called Ronnie Kahavi. So Ronnie Kahavi was in charge of Amazon's A/B testing platform, and then he went to Microsoft, where he runs the experimentation platform at Microsoft, for Bing and things like that. He has tons of data from A/B tests, and his data shows this. Evaluating well-designed and executed experiments that were designed to improve a key metric, only about 1/3 were successful at improving the key metric. This is horrible. This means we could spend 3 of our working days on the beach and deliver the same value to our customers if only we knew the 2/3 of the features that we're building that are delivering 0 or negative value to our organizations. And people often forget the negative value. Features can make things worse. People are like, oh, this is a 0 value feature. I'm like, no, that's probably a negative value feature. you probably invested a ton of work and made things worse. And that's normally not a well-received message. And this stuff that we do that delivers zero or negative value kills us in 3 ways. Firstly, of course, there's the opportunity cost of not building something that would have delivered value. Secondly, those features live forever, and we have to maintain them forever. And that incurs expense. And then third, it adds complexity to our application. And when we have more and more complex applications, that slows down the rate at which we can evolve and change the application. So it slows us down, it incurs maintenance costs forever, and there's the opportunity cost of not doing the right thing. So this is literally killing us. It's the biggest source of, well, it's not literally killing us. I mean, no one's dying here. But it's the biggest source of waste in software development, is the stuff that we build that's useless. And that's actually, this is a bit of a sidebar, but I have an hour and a half. I promise I won't speak for an hour and a half. But this sidebar I think is really interesting. This is actually a function of the way we do analysis and how we do requirements. So who practices Agile in their organization? All right, so you know about the little cards, the 3x5 cards, as a, I want, so that, yay, right? We're familiar with this format. And this is supposed to replace the idea of requirements. And requirements, I hate this word requirements. Requirements, whose requirements are they? Are they the user's requirements? No, they're not the user's requirements. Users don't know what they want. Users know what they don't want once you've built it for them. They're the requirements of the business. The golf playing card drawer who's like, I would like these things, and then they give you a big list, and then you build them all. So they are requirements. They're requirements of the people with the money who pay you to do this stuff. They're not users' requirements. And the problem with requirements is the solutions we think will fix a particular problem without having sufficiently reflected on both the problem and the potential solutions. And so one of my favorite tools to come out in the last few years is this one called impact mapping. There's a great book by Gojko Adzik, which is very short, called Impact Mapping, and it talks about this tool. And what he says is this: requirements are done. Having a conversation and then writing the results of those conversations down on 3x5 cards is slightly better, but it's still kind of dumb. Because actually what we've done is we've kind of decided on the solution and sent it downstream without investigating the possible ways to solve the problem. So what he says instead is, okay, here's a problem. We want to reduce the transaction cost of our trades. This is a financial services example because he's in London. Reduce the transaction cost in our trades by 10%. Who are the people who could influence that outcome? Well, it's the German settlement team, the traders, and IT operations. How could they influence that outcome? And then the third level is like how, and then the final level is the actual features, the ideas that could actually implement that outcome. And so what happens, both in Agile and in waterfall processes, is that you basically have that discussion, and in waterfall, the developers aren't even involved in that discussion. At least in Agile, the developers are involved in that discussion. And then you choose one thing, and then you turn one of those leaves on this graph into the requirement and pass that downstream. Instead of actually thinking, well, these are all possible ways to achieve that outcome, which one do we think will achieve the outcome? Well, our best guess is that the biggest impact with the least effort is going to be option A. And that's what we're always trying to do. We're trying to minimize output, maximize outcomes, which is why measuring lines of code is a ridiculous idea. So we're going to have a hypothesis that one of these things will work, and we don't know which one. And actually, what we want to do, and when we're problem solving in general, is actually expose the entire graph of possibilities and treat each one of those things as a hypothesis, and then test the hypothesis as cheaply and quickly as possible, and then iterate on that. So this is a great idea. We should all do this. But unfortunately, we don't do that. And this happens at the biggest, highest levels of companies. I did another survey a couple of years ago where we asked leaders in organizations how they make investment decisions in products. And the results are really illuminating. 47% said they decide by committee what they're going to invest in as part of their budgeting process. 24% of people said they were using some kind of economic model to make their investment decisions. Woo! For a joke, we put opinion of the person with the highest salary wins out. 13% of people said that was the process they used. Dirty secret is that's exactly the same as committee decides from potential options. Those are actually the same thing, but expressed more cynically. And then product portfolio approach, which is also the same thing as committee decides from potential options, it's 9%. And then 7% confessed and said we have no systematic approach. And what this tells us is that 24% of people use economic modeling to make their investment decisions, and 76% of people don't use economic modeling. So that's the state of our industry today, which is great because it's fabulous to have a low bar to work up from. Things can only get better. And so what we've got to do is actually find ways to collaborate more effectively to solve these problems, both in terms of our ability to deliver code and our ability to actually build things that matter. And the DevOps movement is an attempt to basically solve this problem, to make it so that we can build, evolve, operate rapidly changing systems, so we can do things like take an experimental approach to product development, and make them secure, and make them resilient at scale. So again, the interesting thing about, and this is just my definition, everyone has a different definition by design, but the interesting thing about this, I think, is that it exposes that it's not zero-sum game thinking. We need to get better along all these different axes, and that's what the high performers do. So one of the key practices in DevOps is infrastructure as code, which is basically keeping everything you need to reproduce your production environment and the software on it in version control. And then being able to refactor your production environment by making changes in version control. Oh, I need to move this DHCP server over here because it's getting too much load and I don't want it to share with the DNS server. So I'm going to make that change in Chef or Puppet or whatever, and then it's just going to magically move the thing. That's a refactoring that you're doing to your infrastructure. So infrastructure as code is taking this approach that we talked about earlier, keeping everything in version control. And then what we want to do is build quality in. And the way we build quality in is by making sure every time we make a change, we test it and get feedback. In order to do this, we all need to be working off trunk. And again, the key here is we talked about information flow earlier and the importance of information flow in building high-performance cultures. What's the mechanism by which we exchange information about the state of our systems? Version control. So version control is a great way to find out what's going on throughout the organization. Your ability to use configuration management and version control is a great way to share information and it helps create the high-trust culture. And crucially, the reason we need to be working on trunk is that when you go off and work in a branch, what you're not doing is sharing the information on what you're working on. And when everyone's working on branches, what we're doing is not sharing what we're working on until we try and integrate as part of our kind of release and stabilization phase. And so for me, working on feature branches like that is symptomatic of a low-trust culture. And people say, well, continuous integration, trunk-based development can't scale. And then I like to show them this slide from Google. And again, this is a few years old. And we have some people from Google here, so maybe they can tell me that this is all wrong now. Hopefully not. But they have way more developers than this in way more offices. Probably way more projects under development, but it's built off a single monolithic code tree, and everyone develops and releases off trunk. So as I understand, Google does take release branches just before trunk, so that when they do emergency fixing, they can make the emergency fixes on the release branch and push them out, but otherwise everything gets built off trunk. And you'll notice that the Go language doesn't have any dependency management features, and the reason for that is because at Google, everything's built off trunk. You don't check dependencies in to your projects. You build the libraries off trunk at the same time you build the apps. I believe that's true, at least for some large proportion of what happens at Google. So people are like, we need dependency management in Go. And the people at Google are like, no, you don't. Which I think is kind of a pretty interesting response. So everything gets built from source. And this encourages a culture where if someone's working on a library and it breaks me, I can just revert their change from version control. That's a perfectly acceptable thing to do because you broke me. So collective code ownership has this kind of quite interesting kind of extension at Google where I can revert anyone's code if it breaks me. In order to make this work, you need enormously powerful amounts of continuous integration and test automation. And Google doesn't disappoint in this respect. They have 200,000, and this again is a few years old, so it's probably way more than this now, but hundreds of thousands, if not millions of test suites that they run an insane number of times a day. And it helps that Google has more servers than God, but the fact is that you get feedback very, very quickly on the changes you make. And that's really important. If I break something, I want to know as soon as possible so that I can fix it and so that we can identify quickly which change caused the problem. There's nothing worse than getting feedback a month later. This build is broken. Oh, great, thanks. Or not even that. Between this build and this build, something went wrong. And now we have to do like a binary search of the builds to find the change that actually broke the thing before we can find the person who has forgotten by then what they were working on or maybe quit. And then they have to try and reproduce the problem, blah, blah, blah. So this is really important, the ability to get feedback really fast. And this wasn't always the case at Google. There was actually, test automation and test-driven development was a culture that was developed over a number of years. And there was a whole program dedicated to it, including a program called Testing on the Toilet, where they would print out worksheets with here's some examples of how you can do test automation and put it on the back of the toilet cube so that you can never escape from test automation as part of your job. Literally, I'm going to the loo. Oh, shit. More stuff about testing. So it took them a number of years to implement this culture where everything was done through TDD and testing was considered an essential part of developers' jobs. But this is the result, the ability to actually find out really quickly. And this is essential to being able to build quality in. This is from W. Otis Deming, who is a manufacturing guy. But this applies absolutely to software development. Cease dependence on mass inspection to achieve quality. Improve the process and build quality into the product in the first place. This is one of the cornerstones of lean thinking in manufacturing. It's also true for software development. Testing is not something we do after dev complete. Testing is something we do all the time. The cheapest way to fix a bug is to not check it into version control in the first place, which is why we have automated tests that we can run before we check in. And secondly, quality is not the responsibility of testers. Quality is the responsibility of everyone. We're all responsible for quality, not just the testers. How do we build quality in? We create a deployment pipeline, and this is the key pattern behind continuous delivery. The idea that every time we make a change, we run build and unit tests. We should get that feedback in a few minutes, not comprehensive feedback, but fast feedback. If that breaks, we fix it straight away. And we check into version control on fixing that. No one's checking into version control unless they're fixing the problem. When those tests pass, they trigger more comprehensive acceptance tests. Those will typically take longer to run. For any reasonably complex system, those would take tens of hours to run. We run them in parallel on a big grid and get the feedback, hopefully of the order of minutes or tens of minutes. And if those break, again, someone's working on fixing that as their highest priority. It's not the tester's problem, it's everyone's problem. Once we have a build that passes all the automated tests, that goes downstream for more expensive forms of validation like performance testing, usability testing, exploratory testing, pen testing, and so forth. And then once we have a build that's passed all those kinds of tests, we should be able to push a button and deploy that build into staging or production. That should be like a push-button process. Who works at an organization where that's the case, where releasing software is a push-button process that you can perform during normal business hours? Okay, a few of you, maybe a third of you. Who works in an organization where you work outside of normal business hours to perform a release? Okay, about the same number. So that's the sign that something is wrong. One of my most important metrics for continuous delivery maturity is the number of business hours, the number of hours outside of business hours performing a release. And the goal should be 0. You should not have to have planned downtime or people working outside of business hours to perform a release. That's a sign something's wrong. And particularly like when we celebrate the people who are doing that, rather than being like, I'm really sorry, that's so terrible. When you have like, we worked the whole weekend and we did the release, well done everyone. It's like I'm seeing someone on stage and they're like, I stabbed myself 70 times and I'm still alive. It's like, no, I don't want to celebrate that. That's a terrible thing. What we need to do is fix the problem and actually make it so that we don't have to do that. And to do that, we need architecture. So in order to enable this, and particularly in order to enable, microservices are the hot new thing. But frankly, a lot of what microservices are doing is what we always were supposed to be doing with service-oriented architecture, and in particular, the ability to deploy services independently of each other without having to deploy everything all at once, and the ability to actually get fast, good feedback on the state of the service and its deployability from a development workstation. Works on my machine is often criticized, but works on my machine should actually be meaningful. We have the tools to make that statement meaningful now with tools like Docker and Vagrant and virtualization in general, we should be able to get a good level of feedback on whether our service is releasable from our workstation without having an expensive integrated environment in order to get any kind of feedback on whether we can release our stuff. So that requires architectural change. My favorite statement on architecture comes from Jesse Robbins, ex-master of disaster at Amazon, co-founder of Chef, now working at a startup. And he said this in like 2007 or something, like years ago. Success on the web depends on continuous deployment of reliable software to an unreliable platform that scales horizontally. And here you've got the continuous deployment thing, you've got the reliable software thing, and you've got the unreliable platform. So like pretty much everything you need to know about building internet architecture is in this one statement that was in 2007. It's great. Although I talked about architecture at DevOps Enterprise a couple of weeks ago, and I got schooled for it the next day by the distinguished engineer in charge of DevOps at IBM. So I'm trying to find her name. Yeah, Rosalind Radcliffe. So she's the distinguished engineer of DevOps at IBM. So she has this mainframe background, and she's like, what if you had a reliable platform that scaled horizontally? Okay. That's a fair point. Who's working on mainframes? Well, I guess that answers that question. So the unreliable platform is something we all know about, right? I mean, this is the thing where some AWS availability zone goes down and a load of applications go down, and they're like, look, it was AWS. And you're like, no, it wasn't AWS. AWS very clearly states their quality of service characteristics and that they do not have 100% uptime. And if your uptime is higher than AWS's, you had better architect for that shit. Like, that's an architectural problem. So don't blame the platform when the platform goes down and your application goes down. That's your fault because you didn't architect for that. So in order to actually make reliable software that works on an unreliable platform, we've got to care about resilience, security, scalability, deployability, testability, architectural concerns. And here's the problem, right? If the developers aren't caring about those things, you can't actually call the DevOps fairies to come and wave the magic DevOps wand and reliable and securable your nasty software, right? That doesn't work. And this is why testing at the end is problematic. It's like, oh, that won't scale and it's not secure. And you're like, okay, well, let's just re-architect the whole thing because that won't take long. And developers have got to care about this stuff. One of the most interesting early stories about re-architecture in the internet world is from Amazon. And Amazon doesn't talk about what it's doing, which is like so fascinating for me. So I dig in and find out as much as I can about Amazon without actually having to go to work there. If you read the New York Times, you'll know why. And one of the most interesting rants about Amazon is from a guy called Steve Yege. So who's read Steve Yege's platform rant? Okay, that's good, great. So an advanced audience. For all the rest of you, it's really well worth reading, particularly that bit, which is Steve Yege's telling of the memo that Bezos sent out in 2000, 2001, when it became clear that their big monolithic architecture wasn't actually going to be able to scale. So they basically, Bezos sent a memo to everyone to tell them to re-architect, which is like a crazy thing for a CEO to do, but turned out to be actually quite a smart move because whatever else you might say about Bezos, he is smart. And so Steve Yeager tells the memo like this: all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed, no direct linking, no direct reads of another team's data, no shared memory model, no backdoors. The only communication allowed is via service interface calls over the network. It doesn't matter what technology they use. HTTP, Corba, PubSub, custom protocols, doesn't matter, Bezos doesn't care. All service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interfaces to developers in the outside world, no exceptions. Anyone who doesn't do this will be fired. Ho, 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 jolly Jeff Bezos. And he was pretty serious about that. I mean, someone came out to me and was like, that's terrible. I'm like, I know, I'm not actually condoning this. I'm just describing it. And so he was pretty serious about this. He hired an ex-West Point graduate, a US Army Ranger, Rick Dalzell, whose job was to go around, and if he saw you accessing another service's data through the database, not the service interface, he would shout at you a lot and try and have you fired. And so people took this pretty seriously, which, it's a good thing that people took it seriously. Let's just say that, because, if you build an SOA and everyone's integrating into the database, it's not an SOA. So one of the other interesting things about this is that Steve Yeager says that the developers whined a lot because they weren't able to write code all the time. Now they had to care about production outages and operability and reliability and things like that. And he's like, that's why a lot of developers don't like working at Amazon. And here's my response to that. Good. The developers should be caring about those things because you can't fix them later. It's not something that operations can magically wave the wand. We have to actually care about these things. And if developers spent less time writing horrible code, we'd have less of a miserable time maintaining it in production. So that's actually quite a good thing. But it's a huge culture change. The good news is that we can evolve our architecture without doing big bang re-architectures. There's a pattern I really like that I don't want to talk about in depth, but if you Google Strangler application from Martin Fowler, he basically talks about re-architecting in an incremental way. Who's seen Tomb Raider? Okay, cool. So in Tomb Raider, there's those temples in Cambodia which have the trees going up around them, and a little bird comes and poops on the tree, and a fig grows up around the tree, and eventually the fig strangles the tree, and the tree dies, and all that's left is the fig, which is what you see all over those temples. And so, turns out Tomb Raider, very important source of architectural patterns, including this one. And the idea is basically, when you have an existing monolithic app, you stop changing the app. Instead, when you have new functionality, you write it in new modules which have their own databases or data stores, and you gradually strangle the old application with the new one, and you can incrementally make large-scale architectural change in this way. So the other big piece around Amazon's transformation, apart from architectural, was organizational. I'm actually going to put words into Werner Vogel's mouth, which I love doing, but he did say them, so that's okay. You build it, you run it. So all the people responsible for building the software had to be there to run it. And you don't have to follow this model. Google follows a slightly different model where you do have SREs, as we all know. So people go wild about this model. It's not the only way to do it. But what they did is basically take a very radical approach. They went right to the end of the spectrum in terms of cross-functional teams, and then also having nice APIs around those teams. So one team builds one service. That's the other piece of this. One service, one team, and then that team co-locates with a service throughout its entire life cycle. And that has some nice characteristics if those services are decoupled, because it allows you to manage and independently deploy those services and treat them individually according to their own risk profile, which is one of the things we want to be able to do. But what we're fundamentally doing is saying we want to take a product development approach to service management. And this is the big change we're seeing in service management, is ITSM is moving from this ITIL functional model to actually ITSM being about product development. So we want to treat these services as if they are products. And in the Amazon model, I don't actually recommend burning your developers. But what we want to do is co-locate those people. And the important thing is, there's a lot of fuss about no-ops and how no-ops is a thing, which I find actually very objectionable because operations still exists in this model in two ways. Firstly, you still have operations people on these teams. So it distributes the operations people out throughout the organization. So ops people are still there, but they're on the teams. We also still have an operations department, but what it's doing is a bit different. What it's doing is product development, and the product is the platform. So the reason, does anyone know about the story of AWS and how it was built? There's probably a few of you. So AWS was not initially built as a platform for Amazon.com. AWS was built by three South Africans, Chris Pinkham, Ben Black, Chris Brown, who moved back to South Africa because they wanted to, and Bezos was like, okay, you can still be Amazon employees, go and build EC2. Jesse Robbins was in charge of operations at Amazon at the time, and I have him on camera talking about how the AWS team asked him for servers to build out AWS, and he basically said, no way, keep your hands off my servers, and then tried to have AWS shut down. And so AWS was only able to succeed by building a platform that people would pay them money for. And that, in my mind, is the reason they were successful, is because they had to treat it as a real product. Who works in an organization that's implementing a private cloud? Okay, sorry about that. So here's the thing. A lot of IT organizations treat private cloud as a project. So it's a project, and it's often quite a waterfall project, and we don't actually spend a lot of time thinking about how we can make our developers' lives easier. And I've actually seen situations where after the private cloud implementation, developers still have to raise a ticket and wait days or weeks to get an environment to test in. Has that happened to anyone? Right, that's not a cloud. That's some very expensive virtualization technology that had zero impact on your lead times. We have to treat this as if it was product development and actually make lives better for our users. And the AWS team was forced to do this because the only way they could continue to exist was to make money, and the only way that they can make money was by building something that actually made people's lives better. Don Reinertsen has a nice quote. He says, the way that you find out if what you're doing is valuable is people send you money. And that was certainly the case for AWS. So you have to do product development. You actually have to develop hypotheses about what people will find valuable, run experiments to find out if that's valuable, and evolve your product based on user feedback and get something working from early on and continue evolving it, not plan out an enormous private cloud implementation that's going to solve all our problems and then take 2 years to build it and then find out that by then everyone else is using AWS, including all your internal engineers. So we need to think products, but we still have operations, but they're doing product development, and we still have the machine that goes bing. I want to finish off with a story, another story from Amazon. And of course, Amazon is very heterogeneous, and there's some parts of it that apparently are really pleasant to work in. So I've got a story from Greg Linden from 2006. So Greg Linden is the guy who worked on the Amazon checkout process. He was on the checkout team. And at this point in 2004 or whatever, when you checked out, just what you paid and put in your address and they sent you stuff, he had an idea. You go to a grocery store, and in the grocery store there's a checkout aisle and there's candy. And you're like, I'm not having the candy. And if you have kids, your kids are like, candy, candy. You're like, no candy for you. And they're like, no, we really want candy. And if you had a hard day and you're a bad parent like me, you buy them candy. And then the store makes money. And so Greg had this idea, which is, why don't we do that, but in a personalized way, based on what's in your shopping cart, and compare it against what other people have bought, and when they had the same things as you in their shopping cart. And so he built this prototype and took it to the VP of Products at Amazon. And the VP of Products said, that's a terrible idea. You shouldn't do that. It's going to distract people away from the checkout process, and we're going to lose money. So Greg, a little bit sad, goes back to his desk, takes his prototype, buffs it up a bit, pushes it into production, runs an A/B test, gets back the data from the A/B test, and then, which shows that there's a substantial increase in conversion, like 1% or 2%, which in the context of an A/B test is like huge. And then goes back to the VP product, says, here's the data that shows I'm right. VP product, I'm guessing not that happy about this state of affairs, but doesn't in fact fire Greg and says we should go ahead and build this with some speed. And so, who works in an organization where an engineer, against the express wishes of a VP, could push a change into production? A surprising number of you, advanced crowds, that's great. And at the end of the blog, Greg writes this comment, which I think is so extraordinary, it's broken my clicker. He says, I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a Summit intern or the CTO, any good idea must be able to seek an objective test, preferably a test that exposes the idea to customers. Everyone must be able to experiment, learn, and iterate. And that's true for product development. It's also true for process improvement. We must be able to evolve our processes. That depends on good culture. Good culture depends on information flow. Information flow depends on effective configuration management. I want to end with one comment also about culture. Look around you. What do you notice about the demographics of this crowd? Lots of white guys. Well done. So one thing that I'm trying to get people to do is reflect on why that might be the case. And so I'm going to end with this quote from Shanley Kane. Our true culture is made primarily of the things no one will say. Culture is about power dynamics, unspoken priorities and beliefs, mythologies, conflicts, enforcement of social norms, creation of in-out groups, and the distribution of wealth and control inside companies. So the reason we're a bunch of white dudes is not any individual's fault, but it is our fault as a community, and we can do something about this, especially in this world of chat ops and IRC, where everything you say actually can have an impact on a bunch of strangers. So if there's one thing I want you to take away from this, it's reflect on what you're doing and how it creates these effects, and hence why the people around you look the way they do. If you want to learn more, you can send an email to jezhumble@sendyourslides.com with the subject DevOps. I'll send you a bunch of free stuff. That's great. We have time for questions. What questions do you have? We have microphones? Please use the microphones.
Hi, great talk. Given what's happened in the last few months with VW and lean management coming from their side of things, what are the pitfalls that we got to look out for in IT that we don't do the same as what they did with their delivering cars that broke the rules?
With the pitfalls for VW?
Yeah, VW with the cars.
Yeah. So that's a great question. In terms of lean culture and lean management, how can we avoid making the same mistakes as VW? So I don't know the full story of VW. I don't think we'll really know the full story for VW for probably a few years, certainly months. But allow me to speculate wildly. I think one thing I have to say before I answer that question. Dina, what's the name of the conference that's running side by side with Lisa? URES. You should all go to URES. It's free for everyone. It's running the rest of the day. It's all about release management. Release management's cool. You're all cool. You should all go to URES. It's in Lincoln 5 downstairs. So it all kind of goes back to this diagram, right? How organizations process information. And the scariest thing for me, if it's in fact true, is that the leadership professed ignorance about these things. And if it's possible for leaders not to know these things, that demonstrates that you're working in a pathological culture. And so I think this is kind of the cultural thing that is at the cause of this. In a high-performance organization, people should know what's going on. And we should be able to see these things going on, and we should be able to stop them. And my guess is that actually someone lower down probably told these people to do this thing and didn't tell anyone else because they knew they would get in trouble with it, but knew that it had to be done because implicitly the leaders were saying we have to achieve these results. Like, we must achieve these results. No excuses. And so the people further down knew that technically it would be very hard to do, and it would be much easier to do it by changing the software. It's one of the rare cases where that's true. And so decided that they were going to do that instead. And so Deming has this thing about how management by objectives is a really terrible idea. And I think this could be an example of that, where someone set a very clear objective and has said this must be done, no excuses. And people have found ways to game the metric, but not in the way that they expected, and knowing that they shouldn't tell them how they did it. So that's my guess, but we'll find out. Does that answer your question?
So I actually have two questions. The first one is, you're talking about embedding operations people in development teams. And there's this cycle that we've gone through about centralization, decentralization, centralization, decentralization.
Yep.
And one of the things we lose when we embed people in other teams is there's lots of collective knowledge that you get spread out and fragmented, so you do a lot of duplication. So what's a suggestion to not do that? Or do you think that's a good thing that we're doing duplication of work?
So great question, and you're quite correct to point out that we go through waves in history of horizontal, vertical, blah blah blah. And honestly, this is one of those areas where I think it is a trade-off. There's trade-offs of both ways of working, and I don't think you actually have to go I mean, Google doesn't do completely cross-functional teams. They have SREs, they have development teams, and there's a handover. So it's not the only way to do it. But to answer your question around what do we do when we decentralize people in terms of actually having a community and developing capability, that's a great question. I think, firstly, I would point out that you do still have an ops team. So it's not just operations going into development, it's also developers coming into operations, and you're building product teams. So the teams kind of look the same, whether they're building the platform or whether they're building the stuff that sits on the platform. They all look the same shape. But you still have this problem about capability development. And I think what you have to do is find ways to do that in a different way. You're optimizing for the case where we have fast flow and short lead times, and you're sub-optimizing for information flow in terms of people exchanging stories about how stuff works. So you have to do things like getting the testers together on a regular basis so they can talk about stuff and holding mini conferences. A lot of companies do this now. They hold like a little internal DevOps conf, in some cases quite a big internal DevOps conf, and you could have like an internal testing conf where people talk to each other. So you've got to find ways for those people to get together and collaborate. In terms of duplication, in terms of the systems we build, I think duplication is okay. One of the biggest kind of anti-patterns in enterprise architecture is preventing duplication through standardization by telling people you must use this tool chain or you must use these practices. That's a terrible idea because people need to be able to tinker and experiment to find out what works well, and you basically disempower people if you're like, you will build this, and this is your budget, and these are the tools you will use, and here are the architectural patterns and practices you will follow. Like, you're like, oh great, thanks, I'm a cog in a machine. And so I think you don't want to do that. What you want to do is basically see duplication and then refactor out. And that's true at the small when you're doing development. Developers, if you're doing TDD well, you don't refactor in advance, you do the duplication and then you refactor as a separate step. And that should be true of enterprise architecture as well, where you see duplication, you refactor out. And that, again, requires good information flow in the organization so we know where duplication even exists. So that's one of the important roles of having an architect, is to actually be able to talk to teams and see these things and then talk to them about pulling it out and maybe starting up a team to turn that into a service in its own right. So does that answer your question?
Yes, it does. Do you want me to go with my second one, or do you want to switch to somebody else?
You're the program co-chair. You should do whatever you want.
All right, I will hog the microphone and go with my second question then. So you're talking about productizing and turning the platform into its own product and making teams to do that and having separate services and having a team for each service, which is a great idea. But one of the problems that at least we've run into culturally at work is you have what I will affectionately call legacy services, which are old and crufty, and no one really wants to work on them. And so you see attrition from those teams to go work on other cool stuff or other cool companies. How do you keep interest in those products that are not as cutting edge or cool or fast or shiny?
Yes, that's a great question. How do you keep interest in the kind of crufty old stuff? Maybe a few years ago, someone was using Rails, and now that's not cool anymore, and we're writing all the new stuff in Clojure. And, so I actually find that a bit of, like, that attitude that I only want to work on the cool stuff a bit obnoxious. I'm a language anti-hipster. I do, Nicole can testify, I was doing TDD in PHP the other day. That's fun for me. So maybe you find more people like me who, actually enjoy working in crafty old stuff. But also I think what you need to do, so two answers. One is Google's model is a bit different. So Google, you hand stuff over to SREs once you're not doing like very active development on it anymore. Modulo, how things work in different parts of Google. And the SREs don't really change those services. And in some ways, that's kind of an example of, and I'm simplifying enormously, obviously. That's kind of an example of Strangler. So the dirty secret about Strangler is that there's no perfect architecture for a service. What is the perfect architecture for a service will change over its life cycle and dependent on a number of other factors, such as the changing skills of the people who you work with and so forth. So what we actually should be doing is always doing Strangler application. Like anytime you see someone bring out a like 2B architectural plan of the enterprise, in 2 years we will do this and this will be perfect. You should be like, that's nonsense, because it is nonsense, because what will happen is shortly before those 2 years, that architect will be fired and some new architect will come in and build a new 2B diagram and then we'll all be going in that direction. The reality is situations are always changing, constraints are always changing, technology is always changing, we're always going to be doing this. And so I think, if the crufty old thing doesn't need to change and it's doing what it's supposed to do, leave it. That's fine. But when you do need to change it, take this approach to it. Thanks.
So considering the Steve Yagi rant and the wonderfully flattering NY Times article about Amazon, so yes, they've absolutely done fantastically amazing things. They've also sort of done the psychiatric version of massive, massive pollution, right? I mean, they're hiring mean people to go around and yell at the developers very loudly and giving everyone PTSD and everyone's burning out. Yeah. So how do we do these amazing things without management pointing at Amazon and saying, see, look, this is how you change the culture?
Yeah, that's a great question. And this is endemic in Silicon Valley. Like, the cult of Steve Jobs is the same thing. Steve Jobs he was clearly an awful person. And so, I teach class in Silicon Valley. I teach at UC Berkeley. I teach product management. And I always get a few people who are like, Steve Jobs, he's so great. And I'm like, no, he's not. He's a terrible person. They're like, and so what occurs to me is like, is it possible to build a great company without having it be run by a terrible asshole? And people think that having a terrible asshole is a necessary condition for success. My attitude is like, imagine what we could do if we had companies run by people who are not assholes and how much better that would be. I'm like, actually, those people have held us back, and imagine how much better Apple or Amazon could have been if they weren't run by these people who basically didn't care about the mental health of the people working for them.
But that's imagination. I mean, who do we point to? Who are the examples to say, no, really, we can do this much more empathically?
So Salesforce?
No, we cannot.
Really?
I worked at Salesforce for 4 years. No, we cannot.
Okay. All right. I've never worked at Salesforce either, so thank you for that information.
Etsy.
Who? Etsy, yeah. Etsy's a great example. I mean, I'm sure there's disaffected people at Etsy, but in general, all the people I've spoken to are really happy about working there. So Etsy, that's a good example. And the problem is, like, those examples are very far and few between, because it's much easier to be a massive asshole and send people orders than it is to build a culture of trust and collaboration. John's coming out from the microphone.
Sorry. Amazon doesn't need me to defend them. And I'm like you, I'll never work there, but I'm a junkie of what they do.
Right.
But there's a couple things, meta points that, a couple of people leaving in a mass organization saying how horrible it is. Jeff Bezos, one of the 3 books he recommends to every one of his senior executives is The Goal, right? So anybody who knows about that, the Phoenix Project, it was a story rewritten about The Goal. Chris Brown, who was the original architect of EC2, who worked at Amazon, just went back to work there and is loving life. So again, let's put this in context. They've done amazing infrastructure things. There are some bad stories that came out, and again, they don't need me to defend them, but I don't know that we need to all just put a binary, they're horrible, versus given all the things they've done for our industry. So anyway.
Yeah, I mean, thanks very much, and thanks for the question as well. And I think this is the kind of tension that lies at the heart of this whole thing. Also, Amazon is not homogenous, in the same way that Google is not homogenous. There's many teams at Amazon who have a great time because the managers of those teams actually don't follow this credo that, we should work people for 80 hours a week and that's good somehow. And so in those systems, you find enlightened managers. And really, this goes back to Theory X and Theory Y, which were management theories that were talked about in the 60s. This idea that Theory X is the idea that we assume that people fundamentally are work shy and they need to have carrot and stick management techniques applied to them to get them to do anything. And then Theory Y is the theory that people fundamentally want to do a good job, and what we need to do is provide them the conditions under which they can do a good job. And the interesting thing about Theory X and Theory Y is that you get what you think. So if managers have a Theory X attitude towards the people who work for them, then those people will behave according to Theory X. And if managers have a theory Y attitude for the people who work for them, they will get people who are theory Y. So your attitude towards the people who work for you determines how they will behave. You get what you think. And this is true in other places as well. Nicole and I wrote a paper for Model View Culture where we were talking about attitudes towards brilliance in your industry. And it turns out there was a study that was done that came out in Nature earlier this year that basically looked at the attitudes of the experts in that industry as to whether brilliance was required, like innate brilliance was required in order for you to be successful. And what they found is there's a direct correlation between whether the experts had the attitude that brilliance was required and the proportion of women working in that industry. In industries where there's not the assumption that innate brilliance is required, you find a much higher proportion of women. In the industries where people assume that brilliance is required, you find a much lower proportion of women. And it's basically coupled with the idea that people have unconscious biases where they think that women deserve less money for things and are less likely to be brilliant at things. So these beliefs, it's the beliefs about people that actually create these outcomes. And many parallel studies have been done that show there's zero genetic innate difference in ability between women and men in any of these things. So it's not anything actually to do with how we're built and how we're born. It's about our attitudes toward these beliefs. That's what determines the demographics that we see in these industries. Is that a reasonable way of summing it up?
Wasn't my question, sorry.
Yeah. So this is the thing. Your attitudes determine what you see. Reality is determined. What you get will be determined by your attitudes toward things. And we need to change how we think about these things. And managers often don't think that way. And what's even worse is often they say that they're going to be theory Y, but then they actually act according to theory X, and then everyone can see that they're actually acting according to theory X, and then they'll behave accordingly.
Your examples all come from larger organisations, but it seems to me there's nothing really that would stop all of this being applied to tiny teams, 2 or 3 people. What would you do differently if you're in that situation? You were looking to apply these ideas that have worked at the larger, most successful organisations.
So thanks for the question. It's very ironic for me because 5-10 years ago, I would be talking about continuous integration, and I would have people come and say, well, that works great on small teams, but it's not going to work in our big enterprise. And so here I am here talking about this stuff. Basically, and the reason I talk about this stuff is to prove that you can do it in big organizations. And you're not the first person who's asked me this, is like, does this work? So a lot of this stuff is just XP. And XP was designed to work on small teams. Like continuous integration was a small team practice. Pair programming, test-driven development, these are all small team practices. And for years in Agile, we'd go into places and they'd say, oh, Agile and XP, that's for small teams, can't work here. And so I think what we've shown, the whole reason for all this evidence I've shown is that it works in big teams. But yeah, XP and Agile, these things were designed for small teams. So yeah, trunk-based development, test-driven development, continuous integration, infrastructure as code, all these things are very, very effective in small teams. Thanks.
And all the analysis when you cut it, it's consistent across large enterprises.
Yeah, so thanks, Nicole. So we actually looked at the size of the teams as part of the data that we got, and we found that the analysis applies as we change scale in the same way. Thank you very much. Have a great day.